Now we're going to look at some addition algorithms. What is an algorithm? It's simply a method or a standardized procedure that uses step-by-step terms to explain a process. That's all an algorithm is. So I'm going to show you on this page 4 different ways that you can add, and it sort of like conceptually walks you through how you first teach this and then kind of where you eventually end up. So we can start with base 10 blocks. And so I thought it would be easier in the video, rather than trying to draw all of this, I'm just going to actually demonstrate it with some base 10 blocks. So I have these little ones. I've got my 10s or the blue, the purple is my 1s, and then I do have these are my 100s. And this is just made from it's like that cross-stitch plasticky fabric you can get at like Joann's or Michael's, and you can just cut them into little 10 by 10s and 10s. So that's what these are. All right, so we're going to be adding 67 plus 38. So I have 6 10s, and then I have 7 1s, and then I have 3 10s, and I have 8 1s. So I've got it all displayed there. All right, so if you want to add, what you're going to do is basically group the color groups together. So you're going to put the 10s together, and then you're going to put all the little 1s together. So if I slide and I put all the 10s together over here, right? If we group those first, and if I count how many I had 6, and then I had 3 more, so I've got 90 total. So if I group the 10s together, that gives me 90. Right, that's how much I have. Now, if I group my little 1s together, okay, I have 7 and I have 8. What I have here is I have 15. And if I take 10 of them, if I can get these moved, there's 3, 4, 5, 6, 7, 8, 9, 10. If I take 10 of these, I could turn those 10 into a long. So that's what I'm going to do. I'm going to trade out these 10 for this long right here. Okay, push those off to the side. So now what I have is I have another 10 that I can put over here. So I group 1s into a 10. So that gives me 10. Well, then what I have now, if I count up all my longs, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I have 10 of these, I can trade them out for 100. So I trade that out. Trade 10 10s for a 100. And that's what this becomes, the 90 and the 10, that becomes the 100. And what I have left over are these 5 little 1s. And so I end up with 105. I have 1 of these shapes. I don't have any of the blue long shapes, and then I have 5 of the purple shapes. So again, it's showing each number, each digit is telling you how many shapes you have of that particular digit. So 1 of these, none of the blues, 5 of those. So that's how you add using base 10 blocks, is you group together and then you trade. 10 1s can become a 10, and 10 10s can become 100, and you do this trading. So using an expanded algorithm with partial sums, what we do here in the expanded algorithm with partial sums is we're going to break apart both. Okay, so break up both numbers. So the 67 is going to become 60 plus 7. The 38 is going to become 30 plus 8. And we have 60, because this is all addition, we can change parentheses and move numbers around as we want. I'm going to lump the 60 and the 30 together, and then the 7 and the 8. And I'm going to write it like this: 60 plus 30 plus 7 plus 8. So I just rewrote the order of some of the numbers, and I changed the parentheses, so I use the commutative and the associative properties. So that makes the 10s easier to add together. 60 and 30 is 90. And then 7 plus 8 is 15. And if you think of the 15 as 10 plus 5, 90 plus 10 is 100, and then you have 5. So we use kind of some of those, that mental strategy I talked about earlier. That makes 100, and then 5. And this is directly representative of the 60 and 30, that's those blue longs, and the 7 and the 8 is the purple ones that we had. So this kind of explains the process we did up there. Now using partial sums, you only break up one number when you do this. Only break up the last number here, the 38. So I kept the 67 as 67 and I wrote the 38 as 30 plus 8. And then I'm going to change the order that I add. I'm going to add the 2-digit numbers together and I'm going to leave out this single digit. So 67 and 30, most people can add that in their heads because one number ends in 0. That's going to be 97 plus 8. And if I want to break it up to make the counting go easier, 97 plus 3 would be 100. So I'm going to break up my 8 into 3 plus 5, and then see that 97 plus 3, that's 100, and 5. Obviously, we're getting the same answer every time, right? So partial sums, you break up both numbers. Partial, you only break up the last number. And then the very last thing is the standard method that we were all taught when we were taught how to add, how you carry the 1. So let's see, now it should make total sense if you understand the picture that we did at the very beginning with the base 10 blocks. So we had 7 purples and 8 purples. That ended up giving us 15 purples. And we kept 5, but the other ones got turned into a blue 10. And that right there, when you carry that 1, that was us converting 10 of the purples into a blue. And then we had a blue plus 6 more plus 3 more, which is 10 blues that we had that we traded in for 100. That's how we end up with 100. But it's like 10 blues plus the 5 ones. So I think if you'll start with base 10 blocks, this algorithm makes a lot more sense, because if they've seen it happen like actually in person, they actually worked with base 10 blocks, it makes this more conceptual, abstract idea a little bit more concrete.